Hello everyone, my name is Alisa and my group and I will be talking about titanium dioxide in biodiesel production and how is it used. As of the 21st century, the spread of awareness regarding environment-related issues and emissions of pollutant and energy consumption is growing. The constant rise in the cost of petroleum-derived raw materials, combined with growing environmental concerns, has fueled research into new products made from renewable raw materials, as well as technological solutions that reduce energy consumption, hazardous substance use, and waste production, while promoting a model of sustainable development and social acceptance. Diesel has been around since the early 1900s and has been in constant demand ever since. However, the world will face a major problem since diesel is a non-renewable energy and will eventually run out. The evolution in environmental technology has led to the discovery of biodiesel as an alternative to diesel fuel. What is biodiesel exactly? Well, biodiesel is a renewable, biodegradable fuel manufactured domestically from vegetable oils, animal fats, or recycled cooking oil, and restaurant grease. So, to put it simply, it is an eco-friendly alternative to diesel, which serves the same purpose as regular diesel. On another note, titanium complex catalytic systems having multiple catalysts or a single catalyst with functional additives have been found widely used in recent years. This application has a lot of potential because it greatly expands the range of options for managing catalyst activity and selectivity. Catalysts that contain titanium can be categorized as organic, inorganic, mixed, and complex catalysts. Inorganic and organic titanium compounds both represent the main components of the complex catalyst for the esterification and trans-esterification reactions in the production of biodiesel. Due to the effect of its high surface area stabilizing the catalyst in its mesoporous structure, titanium dioxide has recently been introduced as alternate material for heterogeneous catalysis. The high activity of titanium dioxide nanoparticles for diverse reduction and oxidation processes at low pressures and temperatures has piqued interest in titanium-based metal catalysts. So I know what you're thinking, what does titanium oxide have to do with the production of biodiesel? In order to understand the role of titanium dioxide in biodiesel more clearly, we first must know how biodiesel is produced and manufactured from animal fat, vegetable oils, and recycled oils.
Hello, my name is Radin and I will be discussing on the topic of how the biodiesel production process occurs. As you know, biodiesel is made from animal fats, vegetable oils, and used cooking oil. So that it may be used in conventional diesel engines without clogging the fuel lines, manufacturers of biodiesel must purify the fat or oil before using it to generate biodiesel. First, the manufacturers must guarantee the food stock is suitable for biodiesel production. In the reactor, the feedstock is dried, refined, filtered, and analyzed for fatty acids. Water in biodiesel manufacturing causes processing issues and necessitates low FFA fats or oils, so it is preferred to be dry. Freshly pressed vegetable oil, for an example, such as canola oil, has a low FFA level and would be a great feedstock for biodiesel. More FFA in biodiesel means more catalyst and more glycerin to be removed at the end of the product. After it is refined, the oil then goes through a chemical process called transesterification. And this process is the process of combining vegetable oil, alcohol with the presence of a catalyst to produce biodiesel. The reaction will result in biodiesel and glycerol being separated due to the difference in density. The separation of free glycerol is crucial in the ethyl method because the creation of stable emulsion during the reaction hinders the separation and purification of esters. As you seen in the image, methanol is added to the oil at a 6:1 ratio in a two-reaction batch method. This two-step reaction method technique ensures completeness. When an appropriate feedstock is poured into the reactor is closed with 80% methanol and followed by 80% catalyst, which could be sodium methoxide, sodium methylate, and many more. The reaction mixture is then aggressively stirred for an hour at a temperature of between 65 to 75 degrees Celsius. After 1 hour, the agitation will be stopped and the product will sit for a while, for a few hours. The heavier glycerin sinks to the bottom and will separate the layers. Then the remaining 20% of methanol and catalyst are added again and agitated again, resulting in a two-step reaction. They would then drain the co-products, which is glycerin or glycerol as seen in the image. After the second reaction was finished, the residual liquid is biodiesel. But the liquid still has methanol, catalyst, and other contaminants in it. So the gasoline is then washed with water, which is set between 65 to 75 degrees Celsius with a pH of 4 to 6. The biodiesel is then dried and antioxidant is added. Lastly, it undergoes a mechanical filtration process to remove particles and molecules of impurity, generating a final product of good quality. The completed biodiesel is then put through a battery of testing to verify it meets criteria for use in automobile engines. That's it for me. Thank you.
Assalamualaikum and selamat sejahtera to all my friends and doctor. Thank you to my friend just now explaining about the production of biodiesel. Right now, we shall go into the role of titanium dioxide. Titanium dioxide, in here we can see that homogeneous base catalysts in the transesterification reaction have some drawback, including high energy consumption, costly separation of the catalyst from the reaction mixture, and raw material purification. As a result, heterogeneous solid catalysts such as metal oxides have been lately utilized to lower the expense of the purification process, because they can be easily isolated from the reaction mixture and reuse titanium dioxide. For an example, when utilized as a heterogeneous catalyst, has a wide range of availability and cost-effective synthesis method. The sulfated doped titanium dioxide was reported by scientists as a solid superacidic catalyst that is also employed in the petrochemical sector and petroleum refining process and outperforms other sulfated metal oxide. This is owing to the acid strength of the titanium dioxide particles, which is further improved by the addition of sulfate groups to the titanium dioxide surface. The titanium dioxide with the sulfate becomes as a nanocatalyst, is manufactured and employed in the synthesis of biodiesel from spent cooking oil, such as waste cooking oil. An investigation was made into the utilization of sulfate with titanium dioxide with silicon dioxide as a solid acid catalyst for the simultaneous esterification and transesterification of low-cost feedstock with high free fatty acids. The authors claim that a yield of 92% may be obtained with a mixed oil, 50% refined cottonseed oil, and 50% oleic acid. a 9 to 1 methanol to oil molar ratio, a 9-hour reaction duration, and a 3% catalyst loading, and a reaction temperature of 200 degrees Celsius. These are the conditions that are needed to yield as much as 92% of biodiesel from the refined cottonseed oil and the 50% oleic acid. It was also claimed that the sulfate with the titanium dioxide and silicon dioxide catalyst may be reused up to 4 times without using catalytic activity. In this chemical reaction, the free fatty acids right here reacts with the methanol right over here. We can see that CH3OH with the help of acid catalyst, which is the mixture of titanium dioxide with the sulfate, in order to yield the biodiesel. The above reaction, which is known as esterification, increase the possibility of producing biodiesel at lower cost. That is all from me. Thank you very much.
Hi, my name is Fada Adeline binti Muhammad Fadzil. So, last but not least, titanium dioxide plays a big role in producing biodiesel as it acts as a catalyst that fastens the reaction. It is an alternative support material for heterogeneous catalysts due to the effect of its high surface area stabilizing the catalyst in its mesoporous structure. In addition, titanium dioxide was found to be a good metal dioxide catalyst support due to the strong metal support interaction, chemical stability, and acid-base property. Based on the result of yield percentage from using titanium dioxide as a catalyst in batch production of biodiesel using multiple oil sources, we can identify the optimum conditions that lead to the best combustion yields. Now, you know how titanium dioxide is used in biodiesel. That's all from us, Group C. Thank you.